I'm going to talk to you about inquiry today. You've probably heard the word inquiry or what it means to inquire, which is great news because it's exactly the same in science. So when we think about inquiry, we think about asking questions and getting students to inquire about the world around you. So that's exactly what we're hoping to do with our students when we teach with scientific inquiry. So the goal of this lesson is to think about the different types of inquiry and lessons and to be able to distinguish between them. We're going to do a couple activities to do that after you listen to this PowerPoint, this video. But that's the goal, that there are different types of inquiry and that we will be able to figure out what the difference is. And that's really important as a teacher to know when to use a certain type of inquiry with your class. There is no one way to teach inquiry in terms of which is better with the different types, but it is important to know that there are a variety of ways to do it. So I began by just showing some pictures. This is something that you're probably familiar with. Kids up out of their desks. They've got materials in the middle of their desks. They might be working in groups. You can see that the teacher over here in the corner, she's helping them. But really what you see is that kids are touching items, moving items around. They have some documents here that are aiding them. But this is one signal that you can see that students are inquiring, right? They're participating in inquiry. This is not a case where kids are sitting in rows and a teacher is talking at them. Instead, they have some guides, some facilitation there, but the students are doing the work. Again, here we see this little guy here, and he's working with a robot, and he's got some materials here. Again, we've got the teacher over here in the background. She's helping some different groups, but he's inquiring about what he is doing with the robot. So he's got some different foods here. He is going to be programming the robot to show different foods, which ones are healthy or not. So he might make some mistakes along the way. That's exactly what we want to do within the inquiry process, is to have the students dig in and really figure out what they know and maybe learn something new. Again, here we have, you can notice that the students are recording some data here. Here they were recording different sounds. So they were going to different classrooms and they were recording the sounds in decibels. So they have the parking lot, outside, library. Again, these are things that the students were doing. So another way you can figure out if students are inquiring is if they're collecting data. So that's something else we'll want to be seeing. And then here you can see that the students are drawing some pictures. We have the students are drawing bees because they were studying about bees. All of the students' bees are going to look a little bit different, but there's some similarities to them. And that's another way we can see that they're inquiring, that not all the products look exactly the same. I open with those pictures just to give you an idea of what inquiry should look like in the classrooms. So we've teased out some ideas. They should have some materials in their hands. They should be directing some of the work. They should be either able to be working in groups or be able to talk to each other about their process. So that is some of the basics of inquiry. So I'm going to introduce you to the different types of inquiry now. So structured inquiry, this is something that you've probably experienced in your life. Sometimes it's called directed inquiry, but this is the most structured and the least student-directed. So in this type of inquiry, teacher provides the research question for the problem, the procedure, and the students find the solution. So this would be an investigation where they would compare the weights of two substances to understand its relationship to density. So it might be that students are giving two objects such as water and salt, and they're given the weights and the volume, and they divide the two to determine the density, which one has greater density. They have the materials that are provided, they follow a specific procedure, and they record the results. Then they might answer some questions afterwards. Again, this is called structured inquiry. The teacher's asking the question, they give them the procedure and the materials, and the students follow along. This inquiry is often called cookbook labs, but I will be honest and say that I don't think that that's a totally fair assessment. There are times where it's really important for students to learn how to do these things and to follow steps. And that is part of the scientific inquiry, and they are participating in science in that. What you want to be able to do is ensure that the students have an opportunity to ask more questions at the end. That is a hallmark of inquiry. So maybe at the end of this, you hold a discussion and you ask the students, what are some other things that you're curious about with density? And they might say that they're curious about oil, or they're curious about the density of a spherical object like a ball, and how would you figure that out? So you're getting them to inquire new things. So again, structured inquiry, again, pretty structured, steps, materials provided for them, questions. So that's the first type of inquiry. The second type of inquiry is called guided inquiry. And what this is the teachers providing a guiding question, and the students design a procedure or an experiment and share their own solutions. So again, we're sticking with the density theme here. How can you predict whether an object will sink or float? That is the question, but the students get to design the experiment here. So they would develop their procedure, their hypothesis, their method, and it must be shown to the teacher before the feedback to go on. So, for example, you pose this question to your students. You ask them, how would you design a procedure? You give them support in that, and then they go about conducting that experiment. So you might have a wide variety of materials from the students to choose from, such as oil, different types of solid subjects, like it might be sugar, might be salt, might be balls, it might be aluminum foil, wax paper, all sorts of different things, and some different liquids, oil, vinegar, orange juice, all those sorts of things. And then you let the students try to figure out the procedure for that. The benefit of guided inquiry is there really is that application of knowledge. You might see students making mistakes, right? Not quite understanding how to divide the two to find density, mass over volume, that sort of thing. But learning through this type of inquiry, they will certainly end up with a solid understanding of density when they're done. And so this is an example of guided inquiry. Guided inquiry absolutely can be done from a very young age. I have seen kindergartners do guided inquiry when it comes to plants, when it comes to the amount of sunlight that occurs over different seasons, when it comes to weather topics, determining which months are the rainiest, and all sorts of things in terms of physics, trying to figure out push and pulls with forces. So it's not so much an age thing, but it is about supporting their learning, giving them opportunities to figure this out. The most important part, again, here in guided inquiry is at the end, the students are able to ask new questions. So it might be at the end of this, the students may say, well, now we've done some things with solids and liquids, but I don't quite understand how the densities of liquids can be different. Can maybe we just focus on that, right? Or what if you look at just water and look at ice and water? How does water change with density, right? And you give them an opportunity to think about that. So at the end, the students are asking more questions again. And so this is guided inquiry, and it's an awesome opportunity for your young learners to learn how to design an experiment. What you need to be careful about and really think about being able to provide some materials for them, but also allowing time for them to make mistakes with their experiment. They may come up with a procedure that doesn't quite make sense, but the best thing for those students to do is to attempt to do it and then see if they can problem solve their way out of that experiment. Confirmation inquiry is when the teacher provides the guiding question, the methods, and the solution. And so in this investigation, if we're thinking about those ideas of density, so if we say the addition of salt to water will change the density of the water. And so follow the instructions, record your results in the table given, and answer the questions at the end of the experiment. This can be really helpful after guided inquiry when students, are just trying to confirm what they know, right? So perhaps it's an opportunity for them to just expand that idea. But again, here, this is where the teacher is giving them all three of those things, and then they go through the confirmation inquiry just to confirm that. Again, this is an awesome opportunity for students to follow instructions and also to understand a little bit more about that scientific process. The last type of inquiry is called open inquiry. For those of you who have participated in science fairs, you have probably participated in open inquiry. This is where the students create the guiding question, design their own procedure, and investigate the problem and share solutions that they've arrived at. So, for example, if you're still studying density, design an experiment to investigate any topic area related to density and must be shown to the teacher to receive feedback before implementation. Again, I include that information there because for me, whenever I see open inquiry or even or guided inquiry without any support or feedback for students, I know that can be really frustrating for the students. So making sure that you build in that time for that formative assessment. Would not recommend grading them on that, but giving them feedback, right? Helping them think about it. Open inquiry is an awesome way to think about a final assessment. So could a student, after you've been engaged in a lesson on density, could they do this? Could they come up with this on their own, this opportunity to really engage openly and ask questions that they are curious about? Open inquiry I have seen done in groups with very young children, again, around topics. For example, topics around plant growth or observing fish or animals in an aquarium, those sorts of things. And most certainly, as the students get older, they're able to engage in that. Doesn't mean that they are perfectly designing an experiment that's scientifically sound or without any issues, but what it does is it helps you as a teacher really to understand, do they understand the process of density? So for example, it's pretty quick to tease out if the students have designed the experiment without either weighing something or measuring its volume, then you know that they don't quite understand the relationship to mass over volume for density. So it gives you a really great insight into what students know and need some more support with. Okay, so if we are thinking about this, so the products, if we provide the products provided, say aluminum foil, tissue paper, markers, water, etc., and if they were to create a component for a dollar bill that would make it hard to copy. So for example, this is something that I had my 5th grade students last year work on. So we were studying things about how to make counterfeit dollar bills. And if they were doing something to ensure that it would be more difficult to copy a dollar bill, when they were done, they write the procedure that they use, the materials, and why they think this addition would make it hard to copy. Okay, so what type of inquiry is this? Let's think back to this. So I've given them the products, but and I've given them kind of the purpose, but I haven't told them how to do this. So it's not directed because I'm not directing, giving them the step-by-steps, but it is a guided inquiry here. So this would be an example of guided inquiry. So guided inquiry where the students could come up with a procedure, but I've given them the materials and the problem that they're working on. So again, here would be an example of guided inquiry. And at the end of this, I would definitely want to ask the students, what are they curious about now? Some of the questions they came up with after that were about coins. Other things they were curious about was why did other countries use much more colorful money products than we did. Lots of conversations around the chips and credit cards. So this is a great brainstorming and led to lots more inquiry. One thing I want to bring up is teacher facilitation and inquiry. As you notice from the photographs in the beginning of this lecture, teacher facilitation and inquiry go hand in hand. Inquiry promotes student directedness and teacher facilitation and encourages students to ask new questions. So when we think about inquiry, we need to think about the classroom environment. How can we make sure that the products and the materials are accessible to your young students? They need to be able to get up out of their seats. They need to be able to grab more materials. There's ways you can facilitate that so that it's not total chaos, right? By a materials manager allowing for those checkpoints, checking in with the teacher. But the reason for this is that inquiry and teacher facilitation is to mimic the scientific process, as well as to promote problem-solving skills and multiple ways to solve the problem. One of the things we talked about at the beginning was that thinking about that the products at the end of a guided inquiry or open inquiry are not going to look the same, and that's because the way students direct the learning. And so that's something really important to think about. That said, teacher facilitation is not easy, and this can be really difficult for teachers. So I know that you guys are engaged with your cooperating teachers, and this may be something that they are not comfortable with. But what I find is that when students are given a chance to direct their learning, they really are able to engage in a higher level inquiry than without this. So another inquiry example, I'm just going to click on this. So in this scenario, we were studying birds with our young learners, and we were one of the things we were studying is bird beaks. And so you'll see here, this is a chickadee, and this bird beak obviously is crisscross, which would make it really difficult for eating. And so we were doing an investigation around the chickadees. And so the students were engaged by trying to solve this mystery to investigate different types of bird beaks so they could document any changes over time. So one of the things that we did is we looked at the number of birds affected. So these birds were either starving or they froze to death. So we looked at that data over time and also looked at the data per state. So we were looking at that. We had watched a movie around this, and then what we did is we engaged with the students in terms of investigating why bird beaks are so important. So what we did is we had the students act as if they were birds and bird beaks, and so they each chose a different tool to act like a bird beak. And so, for example, we used tweezers, we used tongs, we used toothpicks to mimic bigger or smaller beaks, and then they tried to pick up food sources such as raisins or marshmallows, seeds, bigger seeds such as walnuts or sunflower seeds, and then really small seeds such as poppy seeds. So you can imagine the different types, like a tong would be really hard to pick up a poppy seed, that sort of thing. Then we gave them different times that they had to use to pick up the seeds, and then we graphed that data and looked at, okay, what is the relationship between these beaks and this types of food source? And of course, what they found out is that certain food sources were easier and harder. Then we repeated this by removing certain food sources and then determined which birds would have been successful or not. So this is an example of a directed inquiry that the students engaged in and were participating in order to understand a little bit more about beaks before they dug in and then looked further into the challenges of the chickadees and what might be going on. So you can often start with a directed inquiry and then engage into some more guided and open inquiry processes, which is exactly what they did. So at the end of that directed inquiry, the students decided that they wanted to try to figure out which food source would match the different types of beaks. So which food sources would make sense if you had like a toothpick type or like a pipette or a larger tong. And so they structured that inquiry to be more about the types of food sources that associated with the beaks. And so that gives you an example of then how the students were directing that learning around bird beaks. Okay, so how do I teach inquiry? So what does a lesson plan look like if I'm teaching inquiry? So typically in science, we use something that's called the 5E lesson plan: engage, explore, explain, elaborate, and evaluate. The reason I like this circular one over here is that I like to think about the evaluation all throughout the process. So typically, we like to begin with an activity that engages the students. This could be a video. So for example, in that chickadee problem, we had the students watching the chickadees try to pick up food. Immediately the students knew there was something wrong with that bird. You know, what had happened with the bird beak, asking lots of questions. They were telling stories about birds that they knew, that they had maybe found in their backyard, right? So you're accessing that prior knowledge and really figuring out what do they know about birds and what are they curious about. There were lots of questions about should you help a bird that's injured and all sorts of things. Then we explored. And so this is where they carry on those hands-on activities with some sort of level of inquiry. So I described to you already about the bird beaks and how the students were engaged in picking up the different seeds and asking really good questions. Then we get to the explain. And this is where there's a good discussion, robust discussion between the students and the teachers. So this is where we looked at the data across the board, asked questions. They were really curious, as I mentioned, about, okay, so what food source matches to what beak type? That's where they would engage in that elaborate. So then we did another type of inquiry that I talked to you about. The teacher helped to facilitate where they each group had one specific beak type with one specific food source, and we tried to figure out which beak was most successful with which food source. And then there's opportunities for evaluation. Of course, a formal evaluation could be asking students about what beaks are used for, what do we know about the data that we collected, right? Maybe doing some analysis there, but also some formative assessment all throughout the way. So that gives you an example that engage, explore, explain, elaborate, and evaluate is something that's really helps you to ensure that you're getting at that inquiry. And so that's something that you're going to be doing in the next project, is thinking about that 5E cycle and what it looks like in a lesson plan.